Japan, an island group roughly 120 million people strong, with a recorded history of only 1,600 years, is the second largest economic power in the world today. In the eye of history, Japan's success happened overnight, and yet it didn't come out of the blue. Cultivating an ancient legacy, modern Japan continues to hold on to its past. Influenced by Shinto and Buddhism, the two major religions, the Japanese have developed many unique methods and techniques that they handed down from one generation to the next. For centuries, Japanese craftsmen strove to become one with their chosen materials, gradually perfecting their methods. And while many traditional crafts are struggling to survive in the modern marketplace, the essence of that knowledge lives on. It was the key to Japan's success, and it still is. I will show you how what the ancients knew helps explain the industrial marvel of modern Japan. To understand Japan's sudden advance in science and technology, it is necessary to understand the country's close relationship with nature and its enduring ties with ancient traditions. The ancients believed that a spirit or kami lived in everything, especially in trees. Because according to an ancient legend, the first Japanese descended from the heavens by climbing down on cypress trees. Both Buddhism and Shintoism, Japan's two major religions, permeate every aspect of life. Rooted in Shinto, the native religion, the Japanese have developed a way uniquely their own, spurring techniques and methods dedicated to finding the spirit, the essence of things. Their search for essence, which shaped modern technology, flourished in the ancient capital of Kyoto. It's here where the ancient and the modern world meet. The buildings in the old part of the city are a testament to the Japanese love for wood. Their spiritual connection with trees inspired Japan's ancient construction techniques. I went to this family home on the outskirts of Kyoto to take a look at something you don't get to see very often. Respected construction expert Kiyoshi Yasui has made it his personal mission to preserve houses that were built using the ancient carpentry techniques. Mr. Yasui had just started the dismantling process. He was taking the entire house apart piece by piece to rebuild it someday in a new site. This was a rare opportunity to see the details of the construction. Mr. Yasui pointed out some of the key construction features. The main pillar. Like the shaft of an umbrella, a traditional Japanese house is built around a central pillar that is connected to supporting beams with intricate joints. The framing is a system of uprights and horizontals. The backbone of the house.
Because this is one piece, long.
Very big pieces. I see. Big indeed. The beam is a single tree, nearly 60 feet long. Influenced by Shinto, traditional Japanese carpenters like to incorporate the natural shape of wood into the design. They even include branches, a natural curvature to elicit the spirit, the kami, they believe lives inside each beam. Mr. Yasui explained the technique in detail that the ancient builders developed to accommodate the varying shapes and angles. The ancients called it the interlocking technique, in which slats and grooves fit together like a puzzle. It moves?
Yeah, move.
I see. So if there's an earthquake, it can bend. Flexibility and durability of the structure rely on these ingenious interlocking joints. This whole joint business is a bit of a jigsaw puzzle, but these guys are going to show me how. Onegai shimasu? At this point, my high school Japanese came in handy.
こういう形にしてあります。これを
These are the daiku, the experts of traditional Japanese carpentry techniques.
するために
Historically, their profession is somewhat mystical, because for centuries their knowledge was only transmitted from master to apprentice. Bring this in to hold it in place. This one. Many pagodas, shrines and private homes are built in this interlocking technique, because surprisingly, the Japanese didn't use metal screws in wood fastening until the 18th century. Pillars are usually constructed from cypress for beauty and durability, which is a major issue in a country with roughly 1,800 earth tremors each year. Ancient methods incorporate other natural materials that enhance it. These internal walls are just made of mud, straw and bamboo, and when there's a really strong earthquake, that's what cracks. But they're easily fixed. Just a few days later, they dismantled the gigantic horizontal beam. It was the 25th house Mr. Yasui saved from demolition, preserving yet another piece of Japan's history for his children and grandchildren. But Mr. Yasui knows that time is not the only threat to the ancient buildings he so cherishes. In 1995, a 6.9 earthquake in Kobe destroyed 100,000 private homes built in the traditional style in only 20 seconds, leaving 300,000 people homeless and killing thousands. However, in the same quake, the taller pagodas remained standing. Although hundreds of years older and built using the same interlocking technique, they didn't collapse. Intrigued by the mystery, I wanted to know more. So I went to the pagoda at Kiyomizu Temple in Kyoto to meet an expert. Hidekazu Nishinzawa is Professor of Structural Engineering at Kyoto University. How does it work? He explained that while the flexibility of the interlocking technique increased the earthquake resistance, the more crucial component was inside. According to Professor Nishinzawa, earthquake resistance is a matter of movement and harmonics. Surprisingly, the secret turned out to be a central pillar. Unlike the one in Mr. Yasui's preserved house, this one didn't provide the central support, but stood like a huge telephone pole in the center of the pagoda. Incredibly, this vertical pillar was attached only to the first floor, but not to any of the walls. So that's the bottom of the pillar?
Yes.
So it's not actually at the bottom of the pagoda, it starts on the first floor?
Yes, at the top of the first floor.
Right.
And that will be rightly connected.
And then it's just floating up there. Look, it's moving.
Yes.
And how does that work? How does the pillar absorb all of that that force?
The vibration mode of the outer frame quite different from the center pillar.
I see. So it absorbs the force from the rest of the building and takes it inside.
Yes.
This is how it works. When the earth moves, the pagoda sways like a snake, leaning against the rigid central pillar, which then counters the movement of the outer structure and prevents it from toppling over. This is the secret to their earthquake resistance.
Slowly.
Can we move
it?
Oh, look at that. That's astonishing.
Yes.
Japan is known not only for massive earthquakes, but for towering skyscrapers. Tokyo especially is famous for them. I had heard that the pagoda design had found a new application there. Until 1968, height restrictions kept Tokyo's skyline well below the current scale. But then, Kiyoshi Muto built the Kasumigaseki building, the city's first skyscraper. Inspired by the pagoda, Mr. Muto designed his building to sway like a willow. Since Mr. Muto's time, many of the principles used in pagoda construction have been applied here in Tokyo's ever-growing forest of skyscrapers. With the earthquake resistance this gives them, only the sky is the limit. The ancient pagoda technology has been incorporated into the construction of one of Tokyo's newest skyscrapers. You can't tell from the outside, but I knew where to look. I met Mr. Tatsuo Inada, Head of Technology and Research for the construction company. He took me behind the scenes to show me the skyscraper's backbone. Mr. Inada pointed out that the central pillar concept had been directly adapted to the 4 pillars supporting this building.
So this absorbs the force and then the force goes up the pillar.
Yes, yes.
Four massive steel pillars form the flexible core of this 37-story skyscraper. Today's engineers modified the pagoda freestanding pillar concept. Using flexible steel plates, they connected the pillars to the building's superstructure.
So that's what takes the shock.
The model shows them as elastic strips that allow the building to sway when the earth moves. So far, no earthquake damage has been recorded.
So it really works.
Yes.
I was fascinated with the Japanese way. During repeated periods of isolation, the Japanese had incorporated and perfected various foreign technologies, whether from across Asia, Europe, or later the US. On the surface, Tokyo struck me as pretty futuristic, but Japan's ancient roots are visible all across the country. One period in history has left a deep mark on modern Japan, the time of the samurai warriors. The symbol of this era became world famous, the samurai sword. Today, its secrets are used to save life rather than take it. There are many ways to keep in touch with history.
The ancient art of Iaido grew out of the sword testers group. Through Iaido, each sword was tested for balance, flexibility, and to see if it would do the job.
To look at the others, you'd think it was effortless. In fact, the sword is rather heavy. This one was approximately 29 inches long and weighed over 2 pounds. To master the various strokes gracefully requires years of practice. But one move demanded immediate proficiency. I had no idea how difficult it would be to put the sword back into the scabbard without slicing my thumb off. Samurai were known for their swords because no one but a samurai could carry one.
The samurai were also known as bushi, and their way of life bushido. It was a way of life whose highest ideals were honesty, incorruptibility, and frugality, a scorn for material possessions. Besides this sword, a samurai's most prized possessions were his pride and his honor.
The Japanese reverence for the samurai and their legendary swords goes back 1,000 years. One sword maker passed his secrets on to the next generation. Initially, the knowledge of metallurgy was introduced to Japan via Korea and China, possibly even India. Yoshikazu Yoshihara is carrying on the family tradition. Now in his 20th year of training, he is well on his way to becoming a master. The steel he uses was smelted in an ancient process which produces tamahagane or jewel steel. It is particularly high in carbon, which is one of the secrets to forging a keen blade. A sword begins as an ingot of carefully selected tamahagane chips, which have been forged together.
By selecting the perfect mix of steels, Mr. Yoshihara is able to take advantage of the steel's natural variations. That might sound surprising, but it's the variations that give the sword its beauty, its personality, and its effectiveness.
The ingot is folded, hammered, and cooled repeatedly, creating thousands of layers, forge welded to one another. Judging by the colour of the heated metal, the swordsmith knows when the temperature is just right. Already the 10th generation master craftsman, Yoshihara Senior, is one of Japan's living national treasures. The Japanese government recognizes him as exemplary in carrying on the ancient tradition of sword making.
What is the secret to making the perfect sword?
Master Yoshihara believes that first you must follow your own nature. If you are natural and firm in your beliefs, yet flexible in the way you encounter life, then your spirit will inhabit the blade and make it perfect. Each sword maker has his own formula. Yoshikazu only admits that his father taught him that at least 13 folds are required. Other secrets include strict standards for heating and cooling. The formula produces an obsidian-hard blade with willow-like flexibility. Finally, it's polished to perfection. Today, the sword's deadly history is easily forgotten in light of its remarkable beauty. 300 years later, the same razor-sharp technology that once took countless lives is transformed to help relieve suffering. Kai Industries in Seki near Nagoya are world famous for their surgical blades. The manager, Mr. Katsuaki Yamada, told me that they spent a lot of time and effort replicating the samurai steel and forging process. Mr. Yamada asked me to try for myself. I was surprised how soft steel could be. In the proprietary process of heating and cooling, the soft and flexible steel is turned rigid. It's all about the carbon. Under the electron microscope, carbon particles are clearly present on the surface of unprocessed steel. After a series of heating and cooling, the carbon particles have been moved inside the blade, giving the steel its strength. As with the samurai sword, the finished steel shows layers produced by folding, lending the blades their flexibility. These precision instruments used for microsurgery are the lasting legacy of the ancient swordsmiths.
In Japanese history, ancient know-how and modern technology often stand side by side. Here in Seki City, a traditional centre of samurai sword making, Kai Corporation is today Japan's premier manufacturer of cutting tools. Just as in the days of the samurai, the best blade is both flexible and one that keeps its edge.
Warfare marked the samurai era. Ingenious security measures protected the supreme commander or shogun from sneak attacks.
It sounds like a birdhouse in here. Even in Kyoto's Nijo Castle, the shogun could never feel entirely secure. So, to prevent any unwelcome intruders, he had a nightingale floor installed. That is, a floor that sings like a nightingale. Here's how it works.
Mounted beneath the floorboards, forged iron clamps rub together, creating a chirping sound when anyone walks on them. Innovation underscored the samurai era right to the end. It was a time of peace. Without the constant threat of war, the life of a samurai continued to be defined by ritual. It was then that the famous tea ceremony developed. The tea ceremony became so popular it sparked an industry, especially in the ancient capital Kyoto. Adorning the tea ceremonies of the samurai, thousands of cups and bowls called kiyoyaki ware were shaped by hand to embody the special spirit of the ceremony. While ceramics are among mankind's oldest natural materials, the production method has remained consistent. Throwing clay for centuries gave the Japanese profound insights into the material's capabilities. Though electricity has replaced the kickwheel, a few potters like Master Imai keep the ancient kiyoyaki tradition alive. He gave me a lesson in the ancient art of throwing.
No.
Good. Very good.
He's just being polite. It's a very polite country. The trick is to keep it even. Now, as the market got bigger and more sophisticated, there was a demand for new and unusual forms. And one of the qualities that they most prized was a tiny irregularity, because it was the irregularity that made the piece unique. Now, the one I've made is certainly irregular, but I should get a second opinion. Dame desu ka?
大丈夫。
Not bad.
Finish? Finish.
今失敗したのを撮ってるんでちょっとだけ待って。
Had enough of this.
土つけて。はい、ちょっと待って。こうして、こうして。
If you're not careful, at this stage all your hard work can go to waste.
Shapes and styles change from one master to the next. But what remains consistent are the properties of ceramics.
Basically, there's not much difference between these roof tiles and this fine ceramic bowl. What the ancient ceramic masters learned was the essence of their materials. By varying the raw ingredients, they could determine the qualities of the end product. Some were rough and porous, while others were white, smooth, and crystalline. The final factor was the heat.
Using only wood for fuel, the early Kyoto potters designed versatile technology that took the basic heat principle one step further.
This is a climbing kiln, a survivor of a technology over 1,000 years old. During the Edo period in the early 17th century, there was a huge upsurge in demand for ceramics, both in variety and volume. Kilns such as this one met both needs.
Big enough to hold hundreds of pieces, each chamber received a different amount of heat. That was the key to this ancient, innovative design.
In a climbing kiln, the heat from the main fire gradually diminishes as it rises up the kiln. At the same time, the oxygen content increases. With that variation, there are changes in the properties of the ceramics that come out the other end.
Tea bowls that were finished with glass-like glazes required higher temperatures, so they're fired at the bottom. Earthenware, like that of Master Imai, doesn't require a hard finish, so they would have been fired higher in the kiln where the temperature was lower. The more I looked for the role of ceramics in everyday applications, the more I was struck by how much every culture around the globe has relied upon this material throughout history. Yet it was the Japanese who expanded their ancient knowledge of ceramics into an entirely new generation of materials that changed our lives forever. Many ancient technologies are dying out. Yet in Japan, old and new live side by side. What their ancestors knew is utilized by the Japanese of today to pioneer new applications. When it comes to electronics, Japan revolutionized our world. Searching for the essence gave the Japanese a conceptual and eventually an economic advantage.
In Japan, miniaturization is an ancient tradition, and so far, no one can tell me exactly why. What is clear, though, is that in the electronic age, this philosophy gave Japan the edge.
At a modern ceramics factory, I saw how some of the ancient techniques contributed to the most recent advances in miniaturization. The founders of Murata Manufacturing proudly traced the origins of their company back to the 17th century, to the ancient ceramic traditions of Kyoto. Instead of crockery, they now make electronic components. Mr. Tetsuya Ikeda, Murata's head of development, introduced me to one of their basic ceramic products.
Tetsu, can you tell me what are we looking at?
Yes, here is a ceramic circuit board.
Circuit boards.
Yeah.
What are they?
After centuries of working with clay, scientists at Murata changed the course of technological history. They developed innovative ceramics. Just like the classic material, they can be molded into any shape. But what's more, they have electrical properties. The ancient wood-burning kilns have been replaced with electronic ones that operate at precise temperatures. From mixing the components to the cooling of the finished boards, precision control is the key to success.
Is it really hot when it comes out?
Yeah, not hot, because the cooling zone here.
It's cooled, okay.
Yeah. Let's see the substrate.
These circuit boards are fine-tuned ceramics with added properties.
And that's completely it. This thing is ready to go.
Yeah, completely fired. Yes.
Here's the difference. Classic ceramics are not electrically useful. But when Murata combined suitable ceramic metal oxides, they created a variety of technical ceramics with exploitable electrical properties. The internal microstructures of these dielectric ceramics react in different ways when voltage is applied. While some ceramic compounds block electron flow, others respond mechanically, causing a component to vibrate or pulse and do things like make your cell phone ring. My next stop was a controlled research area.
Okay. The film is a ceramic.
Yeah, film ceramic.
In this contamination-free area, they're working on a brand new experimental component. The base is a mixture of technical ceramics, which is sparingly applied to a thin plastic film. Once fired in the kiln section of the processor, the already super-thin ceramic film shrinks and becomes thinner still. In a secret process, layers of micro-thin ceramic films are used to build up complex electronic components. One such component lies in these fantastically tiny capacitors that will provide increasingly smaller memory circuits. From crockery to electronics, it's really amazing how Japan was able to transfer an ancient technology into our modern times. But the ancient origin of a tool used to inspect today's powerful microchips is even more amazing. Tokyo's bustling Akihabara district is one gigantic electronic bazaar where you can find the latest in compact personal electronics. Here, it's clear how the small approach gave Japan an edge. You can find a miniature anything.
In Akihabara, the sheer range of gadgetry is mind-boggling. Even the features on a cell phone can make you dizzy.
What makes them all possible is an essential component of miniaturization, the microchip. Microchips are basically tiny silicon wafers with circuits etched onto them. The surface has to be perfectly flat to ensure reliable connections. At Yamashito Denso Corporation, Mr. Masaki Yamashito, the chairman, introduced me to a surprising modern application of an ancient technique. This machine, called Magic Mirror, checks polished silicon wafers for any imperfections. Here's how it works. Light rays hitting a flat surface bounce off at the same angle. Any deviation in the surface causes them to bounce off in different angles. These imperfections are so slight, you can't see them with the naked eye.
It looks good.
Using this reflective principle, the machine can detect surface imperfections down to 2 to 3 nanometers, that is, 2 to 3 billionths of a meter. They're shown as dark areas wherever the surface isn't flat. For the wafer to be used for chips, the image must be completely white, that is, free of any deviations, like this one. Magic Mirror, or Makio technology, has become a world standard. But why is it called Magic Mirror? Once again, the answer lies in the past. An ancient technology imported from China, the Magic Mirror had a revival in mid-16th century Japan. At this time, Christianity was considered a foreign influence and an obstacle to establishing absolute control over the people. To be Christian was illegal. Showing your faith in public could cost you your head. However, during this dark period, the magic mirror saved lives. The magic began with a copper plate that was cast and polished under a master's hand.
The real magic of the mirror is its precision. The image is carved on the reflecting surface so subtly that if you look at yourself in the mirror, all you see is yourself. But if the mirror reflects white light, it tells a different story.
Thanks to the magic mirror, Christians could secretly identify themselves to those who shared their faith. The light-reflecting principle of the wafer analyzer goes back centuries to this ancient technology. To find out how the image got inside the mirror, I visited a traditional workshop in Kyoto. The Yamamoto family has been making magic mirrors for nearly 200 years. They follow an ancient process with a few modern touches. Copper is melted at about 1300 degrees centigrade in this small gas furnace. While it's a secret family recipe, some say that the best mirrors are made of 5 parts lead, 15 parts tin, and 80 parts copper. A little burnt straw filters out any surface impurities as it is poured into the mould. It looks simple enough, so I thought I'd give it a try.
Okay, this makes me a little bit nervous. Oh, it is unbelievably hot. Oh, hotter than 1,000 barbecues. And now the trick is to pour it without spilling it and burning my feet off. I feel like I'm burning my face off, and there we go. Let's see if that one comes out magic. Somehow I don't think so.
Two hours later, the mould has cooled and the cast is broken out. The copper plate is blank on one side. Today, the other side displays a Buddha. However, during the persecution, a false back concealed the Christian image. Then the magical process of finishing begins.
Mr. Yamamoto is the 5th generation in a family of magic mirror makers. He's been studying the craft here in his father's workshop for 8 years, but he still has another 2 years to go before he can call himself a master. That's how long it takes to learn the touch.
Scraping and polishing creates microscopic surface variations on the front that produce a reflected image similar to the one on the back. It takes weeks and a progression of ever finer scrapers to create the image on the mirror surface.
Mr. Yamamoto uses a piece of charcoal like this for the final stage in the polishing process. He can't actually see when he's got it right. He has to feel it.
The entire process takes about 3 months, start to finish, even for the most skilled craftsmen. Only an experienced touch will eventually reveal the magical image.
Once the mirror has been polished, it's coated with a thin film of nickel, at which point it looks exactly like an ordinary mirror. For the final stage in the process, it's taken outside to check that the image on the back reflects through the front. If the light is right, it does.
The ancients' quest for essence, a deep understanding of the materials and their reverence for tradition, paved the road. From classic ceramics to electronic ceramics, from magic mirrors to state-of-the-art inspection devices, and, surprisingly, from this 17th century samurai doll to the 21st century robot. Many of Japan's modern technologies are based on adaptations that go back 300 years to the Edo period. In the 17th century, a European mechanical clock was brought as a gift to Japan. It that would spark an unimagined innovation. During the Edo period, science and technology focused on the search for Ri, the underlying principle of nature. When craftsmen got a look at the clock, they were so awed by its movements that they dismantled it to uncover the force that drove it. Springs and gears were concealed inside, lending the clock its wondrous magic. This was the beginning of karakuri, a tradition of mechanical devices designed to take you by surprise. Their belief was that technology should be an extension of human actions, and so the ancients designed humanoid dolls and puppets. Based on the clock, their mechanism stores energy when it's wound up, which, when released, translates into motion. In the karakuri tradition, the technology is concealed, so you don't know why a device does what it does. To the ancients, that was magic. In this case, the surprise is that the chahakobi ningyu, or tea-serving doll's mechanism, is triggered by a teacup. Designed to evoke a feeling of wonder and mystery during samurai tea ceremonies, it was Japan's first home entertainment robot. Today, the karakuri doll might be nothing more than an expensive collector's item, were it not for one modern engineer's reverence for the ancient technology.
The karakuri doll has a new home in the Aishin AW company. Here, it's been reinvented as a state-of-the-art energy-saving device.
First mission.
Mr. Shigeharu Ikeda, Aisin's chief engineer, explained to me why he'd become interested in the karakuri doll.
That's the old machine.
In this plant, heavy transmissions are moved from one assembly point to another on complex electric trolleys.
Motorized.
For such a simple job, he thought there had to be a better way. Recalling a clever mechanism from the past, Mr. Ikeda copied the ancient wooden karakuri doll using modern materials. Two properties of the karakuri mechanism drew his attention. First, Mr. Ikeda realized the enormous energy that can be stored in a spring. Secondly, how weight can be used to release that energy to power a set of gears. Reconstructing the ancient mechanism inspired a nifty adaptation. This is the doll mechanism's new function.
So now you're going to explain to me how this one works.
To move his heavy transmissions, Mr. Ikeda built a karakuri cart. The cart is driven by industrial springs and gears. The weight of the transmission forces down a drive gear and compresses the springs, in essence storing energy.
Yep. So the weight of it actually. Yeah.
The transmission slides onto the cart, releasing a catch that allows it to move. When the cart reaches the point of transfer, on impact the momentum carries the weight onto the conveyor. The springs are released, turning the gears that move the cart back to its starting position. No external energy like electricity is needed.
That's amazing.
Adding a welcome side effect to the karakuri doll mechanism by cutting energy costs significantly. So after 300 years, the spirit of the karakuri doll lives on in this modern factory.
If you think that's cool, wait till you see this.
At the expo in Nagoya, Japan's vision of the future became apparent. The exhibition's theme centered on the spirit of nature and humanity in their relationship with modern machines. Robots will be a part of our world. Nowhere is Japan's ancient fascination with the karakuri doll more obvious than here. Its It's rather amazing, but they told me these robots really played this music. The Japanese belief in Ri, the hidden force inside a machine, has triggered a gigantic industry to produce humanoid robots. Japanese kids love them. From an early age, they learn how to interact with them. For me, on the other hand, talking to a robot was a totally foreign experience.
According to his resume, this guy speaks 4 different languages. Hello, robot, do you speak English? Maybe he's a little shy. Robot, can you tell me where the theatre is, please?
This is Robot Theater, correct?
Correct.
Leave through the rear exit and turn left. Turn right at the T-junction and you will see it in front of you.
Thank you very much.
While the robots at the expo were fascinating, a glimpse of our future relationship with machines required a visit to an already legendary humanoid. Dr. Hiroshi Kobayashi built Saya, the receptionist.
These are the words she knows.
Yeah.
Can we try them?
It took him 12 years to create her emotions.
Konnichiwa.
こんにちは。大学のこと、私、さやについてご案内できます。大学、さや、どちらにしますか？
Genki.
元気よ。
She's fun. Kora.
どうしたの？
Baka.
バカじゃないわよ。
Sawarasete.
嫌よ。
Tatakuyo. Bye bye.
バイバイ。
In the spirit of Karakuri, the robot's mechanism is hidden. But it was something straight out of a sci-fi movie.
Okay, actually there are almost 20 points on the face.
After processing by a computer, the spoken word triggers a sequence of mechanical actions. 19 compressed air lines with special constricting sleeves are attached behind the robot's face. Compressed air causes the sleeve to contract and elicit 12 facial expressions.
Yeah, by pulling the...
By pulling it?
Yeah.
But why do you go to such trouble to produce something that looks like a human being? Why not just have a box that talks?
Yeah, because really is very important for the communication between human and robot. That's why I concentrate on developing the very real robot.
Okay. In a sense, you want to convince someone that they're talking to a real human being. Well, you're well on the way.
If history is any indication, Saya's example shows just how far ancient technologies can go.
バイバイ。
Certainly 2,000 years ago, Japan's silk weavers would not have imagined the impact of their craft, particularly not in the field of biopharmaceuticals. And yet it was their ancient knowledge that provided genetic engineers with the clues for a life-saving protein. The northern parts of Japan's countryside are lined with rows of trees like these. At one time, they were the source of the nation's wealth.
The miracle of silk begins with the mulberry. What goes into the silkworm as a leaf comes out as silk, a process the Japanese have been exploiting and studying for centuries. But now, in the days of cotton and polyester, the process itself is being transformed.
It's amazing to think that silk has been a part of Japan's culture for over 2,000 years. Sericulture was brought to Japan around 300 BC. From that time on, families throughout Japan produced the treasured fabric by hand. A kimono created out of handmade silk is a cherished heirloom that can run as high as $40,000. The cost lies in the craftsmanship. In the ancient silk-producing centre of Yuki, a few traditional workshops remain. Here, silk fabrics with intricate patterns are woven on looms, inspired by the ancient Chinese technology. But generations of masters like Akira Sudo have perfected this unique knot-tying process. He's preparing the thread for the various dyeing phases that eventually create these subtle patterns. But first, you've got to have a thread. It's the secret of Japanese silk. Silk fibre is a secretion from two glands in the silkworm's head, which creates the cocoon. To make the cocoon, it only takes the worm 2 to 3 days to spin a thread that is more than a mile long. The silk dries when it comes in contact with air. Mrs. Murata showed me how in the ancient tradition the thread is loosely twisted and not tightly spun. Konnichiwa. Arigato. Arigato. It takes real skill to unravel silkworm cocoons.
Once the cocoons have been boiled, the silk is pulled and twisted into a thread. The saliva makes it smooth. It's actually harder than it looks, but the real trick, getting the silk always the same thickness, takes a long time to master.
After a year of hard work, these pieces of art are the reward for the highly skilled craftsman. And as more synthetic thread is used, traditional silk is becoming increasingly precious. The miracle is that the silkworms may hold a new promise, which science is just beginning to explore. The National Institute of Agrobiological Sciences isn't far from the ancient silk town of Yuki, but it is light years away in terms of silkworm production. I met with Dr. Toshiki Tamura, the lab's chief geneticist. And here they are, the little wonder worms. There are more than 1,000 different kinds around the globe, and Japan is familiar with over 600 of them. Given Japan's history, it is no wonder that its scientists are leading the decoding of the silkworm's genome.
It's a little strange.
Turns out that silk is a protein. Scientists here in the insect factory of the NIAS are experimenting with genetically modified silkworms that produce not silk, but proteins that can be used for medical purposes. A revealing test shows they're making progress. The first challenge is to redesign the silkworm's DNA to accept a new gene. To test the concept, Dr. Tamura's team is injecting the jellyfish gene for luminescence. If they can splice it into their DNA, worms from these eggs will glow green under ultraviolet light. These genetically engineered silkworms could produce useful proteins such as interferon, which is used to fight cancer. If successful, the new biotechnology could make Japan a major player in the hugely profitable pharmaceutical market.
What is he looking at?
He's the worm.
Yeah, he's looking for, actually you can see here.
Dr. Tamura explained that the green glow is proof that the fluorescent jellyfish gene was successfully introduced into the silkworm's DNA. The next stage is crucial to the team's success. The key is to get a new gene to affect the silkworm's protein.
What is this?
This is a cocoon. Yes.
The glowing cocoon means the biotech splice has been a success.
Okay, so this is the proof that the process works.
Yeah, as you can see here.
The team is well on its way to transforming the silkworm into a cancer fighter, adding yet another innovation to our modern world based on what the ancients knew. Walking around Tokyo that night, I was amazed at how much modern Japanese technology is rooted in ancient traditions. Whether tea-serving dolls transformed into robots, or ancient carpentry techniques built into earthquake-resistant skyscrapers, Japan's ingenuity seems to recharge itself by looking into the past.